Hi everyone, just letting a few more of us in. Um, so during this time as you're waiting for us to get started, please make sure that you go to Google, open up your own copy of today's slides. We are on day nine here today, and it's Thursday. Or like this is your last day of full set classes, and tomorrow you just have advisory, and then next week everyone's spring break. So we're almost there. Um, so that's exciting. All right, let me go ahead and get us started and with our check-in question. Okay, so I'm curious to know, what are you looking forward to during your spring break next week? What are some things you're looking forward to? Go ahead and stick that into the chat, and we can see what we're looking forward to so that we could hold on to that as we get through today. Because, it's a hard day. We got our classes, four if you count advisory. All right. Okay. I love this. We're looking forward to not coming to class. Yeah, not having to actually like log into Zoom. I totally feel that. I definitely will be looking to the sleeping. For some reason, I don't know. This week I feel like I overworked. Don't know why. Like what had happened. I just feel that way. So I definitely look forward to sleeping. Ooh, anime and manga for some of us. That's awesome. Me too. I want to do that too, but not manga. I haven't actually gotten into manga, but I'm curious about it. Oh yeah, grad picks. Yeah, for seniors, the actually for all students, seniors and juniors, the deadline for April 4th. Quick plug there. Make sure you let Mr. Garcia know if you have questions. We're having time to read more, relax and crochet. I hope I'm saying that right, crochet. I always wish I knew how to do that. We got yard work. I'm working on projects. That is awesome. Sleeping, definitely. Catching up some reading. Mental break from work. Yes, I need that as well. We have sleep and looking forward to work. I mean, that's cool. Looking forward to some work. That's cool. We have some more sleep, relaxing, college work, sleeping. Oh, seniors, don't forget to check your portals. Sorry, quick plug on that. Nothing I work. No, at least in that minimum, you don't have to worry about schoolwork or any assignments that are due. But I feel you if you're working for next week. That must be tough. All right, y'all. Thank you so much for sharing. Let me go make sure I update the attendance. So a few of us have some stuff to look forward to. I definitely agree with the sleep part. Let's see who we're missing here today. Okay, so I am missing Carla. I am also missing Alicia. I am missing Marco. Um, Bianca. Am I missing Bianca? Just making sure. I don't know if that was an accident. Yeah, I'm also missing Bianca. So let me make this a more certain list of who I have absent. Here we go. So I'm sorry, here fully. I am missing Tyree, Dennis, Jorge, Kayla, Alicia, Marco, and Bianca. If you're actually here, please let us know so I can fix the attendance. And I apologize if you're actually here. Okay, so it seems like I got that right. So I'm going to go ahead and hit submit. Again, if you're friends with any of these folks, send them a message to come on into our last class before spring break. Yes, I also put like a picture of a stretching, but then you're a warrior because we need that inner strength today. It is Thursday. We got this. We have 3 classes. We got this. Okay, so here's our agenda today, everyone. I just took attendance. We will take a look back at that Google form y'all did the other day where you were creating an equation from a sinusoidal graph. Remember that's a sine or cosine graph. We're going to look back at that and kind of see what is the correct answer. We're going to finally take a look at the big ideas packet. Now, let me tell you, we were still working on this big ideas packet. That's why it didn't come out as early as I wish I would have had it out, but it is finally done and posted. But what we're going to be doing today is like a whole class. Like everyone jumps on that document and we're all going to add like one comment or question, on that document. And hopefully we'll have some time to get talking about that mini final. Um, Part one of it was due last night, and I've set part two due for Friday at midnight. Yeah, so I guess, yeah, we'll call that async number 13. That is trying to finish up your draft, part two of the mini final due Friday. So again, what you turned in on Friday is a draft. So don't worry about it being marked yet for like proficiency. That's not going to happen until after we come back from spring break. So when we come back from spring break, there'll be time for revisions. So what I'm asking for is the draft, the full draft on Friday. So tomorrow, midnight. Does anyone have any questions about our agenda or anything about that mini final? Go ahead and feel free to put it in the chat, or any questions about makeup work, anything like that. Feel free. Okay, I don't see any questions. If anything comes up, just go ahead and put it in the chat. Feel free to unmute. I'm going to go ahead and take us into reviewing how to create an equation from a sinusoidal graph. Quick recap of what we did the other day. We actually got deep into some math. We had to solve for the parameters of a sine function, specifically the parameters of those things labeled with letters. So right here, A, B, C, and D. We solved for these by using these formulas that you see right here on the left-hand side. Not only that, but we also had to have a copy of the parent function right next to us so we can make comparisons and maybe use some shortcuts if we saw any. So that is what we did yesterday. Sorry, not yesterday. I think it was the other day for you all. I think on Tuesday. And after that, there was a Google form. Um, Before we actually did the example, we went over the definitions of different portions of a sine wave. Again, any wave like this is called a sinusoidal graph. Cosine is also one. But these are the different definitions that we went over. So that is a little bit of a quick recap. Let me know if there's any questions. If not, I'm going to go ahead and transition us to slide number 5. So what I have for you pictured right here is the problem y'all did on the Google form on Tuesday. So you were asked to create a sine function that would represent this sine graph that's here in purple. So basically what that means is you're asked to solve for A, B, C, and D of this sine function right here. Now, before we actually talk about what the correct answer was for this, I want to actually show you the various different patterns I saw in your answers. So I am transitioning to slide 6. These I'll go back to later when I actually do the correct answer for this. Okay, so I just took a quick screenshot of the various different things that y'all had put for representing the equation for that purple purple wave. There we go. So go ahead and take a look for it. Start to think about what's similar and different about the responses. And then I'll go ahead and give my 2 cents on what I see when I look at this. Okay, so I first wanted to give you all time to just take a look at the different things. In particular, I do like how this response right here kind of gives a little background explanation to where the numbers came from. So that gives me a little bit like more information into how this particular student is answering. but I could still analyze the other responses anyway. Um, so one thing that I'm noticing is the B term. I'm noticing that a lot of students for the B term had put 2 pi. And I feel like that has a lot to do with the fact that the period of a function, its definition, was that it was equal to 2 pi divided by the absolute value of b. Like I'm feeling like that's where that 2 pi is coming from. So that's just my little notice and wonder there of like a common trend that I've seen. Awesome. Okay. Another trend that I'm seeing is the various different answers that we're getting for the vertical shift. That means that D term. Oh, I also like that this is written here so I could reference it. So the thing I just talked about was that B term. I'm noticing that 2 pi was written commonly for B. Now let me talk about a different notice for the D term. Right here, this student thinks it's -4. This student thinks it's -5. I see -4, -5, -5. I also see a -4 over here, but then I also see a -6. So I'm seeing like -4 and -5, kind of like a trend for what the vertical shift is. So when I talk about how we do this problem correctly, I'm going to focus on the B and the D term. So we could talk deeply about that because that's where the different answers are coming from. So before we do that, I actually have a Padlet for you all. That's going to be today's first credit. So before I leave on this slide, let me know if anyone has questions about what we just did here. It just kind of pointed out what was common and different among these responses. It kind of lets me know what are common like misconceptions or anything we should zoom in on. Okay, I went ahead and cleared my screen. So we could go ahead and go to the Padlet now. In the Padlet, what you're doing, and let me get you all the link first. If you're on the slides with me, awesome. We're on slide number 7. There we go. I put the Padlet into the chat. We're going to go to column number, I believe it's 11. And what you're going to be answering right now is basically you're thinking back to that problem you did on the Google form on Tuesday. You're kind of thinking back to it. Oh, I'm sorry. We're on column number 10. My bad. You're thinking back to that Google form you completed. And in column number 10, I want you to think about what questions do you have about this Google form problem. If you don't have any questions, you can also go ahead and put like, what were you certain about? Let me just add that in. Or confident about, there we go, let me rephrase that. What questions do you have and or what were you confident about when it came to seeing this problem on Tuesday? Great, I see a few folks are already starting on this. Let's go ahead and have about a minute for everyone else to put their thoughts on what you thought when you first took a look at this problem. And then we're gonna come back and address some of those. All right, let's be back in a minute, but let me again put the directions in the chat. All right, and in about 1 minute, we'll be back, y'all. Okay, everybody, coming back. So I was taking a look at the questions that were coming up for us when we did this Google form. Ooh, okay. So one thing definitely is that horizontal phase shift. So there was a phase shift, but how would you solve for it? Any examples we could follow? That is a good question. That might come up in our big ideas packet. We have that it was honestly kind of confusing. So I think that was a reoccurring theme I saw. Oops. Okay, so like we're having a general understanding of the equation, but like we need a little bit like more detailed, like how we could, find each portion. Another thing that came up as I was scrolling down here is how the graph being negative. So I'm assuming that means it being below the x-axis. How is that going to affect it? That came up a lot as I was reading through this. And does the examples that we learn in the recap apply this type of situations when they're below the x and y axis? I could answer that yes, it does. Um, but unfortunately, in our example yesterday, we didn't really talk about the phase shift. We could talk about that today, so that's why it's great to bring this up. And then there's more confusion. Let's see. That's a good question. Is there a way we can kind of like verify our work to see if it's correct? Usually, like when I find certain terms in a function, I try to like either graph it on Desmos and then just see if it matches up. That's how I would kind of verify it. And that's what you all could do when you make your sound waves in your mini final. Okay. So there's like a bit of uncertainty. Okay, awesome. So thank you so much, y'all, for participating in that Google form. Let's try to tackle this problem. Okay. So let's do this. So I actually did not kind of like create, you know how usually when I do these problems, I actually like type it out on the slide. Instead of doing that here today, I'm going to try to use my annotation tool. Number one, why? First off, I didn't have time. Number two, so number two is because sometimes it kind of is benefits when you see somebody writing out like their steps and their thinking process rather than having it just pop up on a slide like I do. So, I mean, I noticed that when I was in the classroom, sometimes I would work on the board and that had like a different kind of effect than when I would use it on a slide. So let's try to see if that helps. Um, okay, here we go, y'all. So things that need to pop up are your original graph and any formulas that you might need. So this, by the way, y'all, be prepared for a workout. So one of you mentioned it did have a phase shift. That is correct. In the example that we did the other day, it did not have a phase shift. So I was totally interested to see what anyone came up with that. But of course, that's going to be a struggle point, but because we didn't see an example of a phase shift. So um, nextly, we could go ahead and address like the amplitudes and the D portion, which I'm sorry, the B portion and the D portion of this function, which I definitely want to focus on given the variety of responses that was on the form. So here we go. For me, I like doing amplitude. So the steps to finding the amplitude, that is the green part right here, amplitude, the absolute value of A. That's going to be our A term. Step one, in order to find the amplitude, you draw your midline first. The midline is the line that cuts your graph directly in half, but horizontally. It goes right between the maximum and minimum points. So right here, that is my midline. Now remember everyone, I saw various answers for the amplitude. So we definitely want to make sure that we understand how to find amplitude here. The tip that you want to focus on here is you want to make sure that you are not counting the boxes. So we're not saying this is 1, 2, the amplitude is 2. No, you want to pay attention to your scaling. This goes from -5 to -4. And the distance between -5 and -4 is 1 unit. Because that distance is 1 unit, our A is equal to 1. Let's see if anyone has questions about that. Okay, no questions? We also you just need more practice though too. Okay, so that was A. Now let's go ahead and tackle B. And I mean, I didn't really color code my A, but I'm gonna start to color code now. So for B, in order to usually solve for B, what we need is we move on to this blue portion because you notice you have your B parameter in your equation. I'm just gonna go ahead and go to the side over here and I'm gonna write my formula I need to solve for B. Period is equal to 2 pi divided by absolute value of B. Okay, let's go ahead and plug in what we know for this particular purple function. One thing I don't know in this formula is B. That's what I'm trying to figure out. Like, what is B? But there's another part of this formula that I could figure out. What about P, the period? If I know the period of this purple function, I could plug it in for that P variable. So let's try to find the period of this purple function. So in order to find the period, the strategy is you identify either two maximums or it could be two minimums. They have to be right next to each other. And what you do is you measure the distance between those. And in order to find the distance between those, you got to use your x-axis like a ruler. So that is a strategy. Let me go ahead and identify. So I see a maximum here and a maximum here. I'm going to go ahead and just go ahead and identify those. And I need to figure out the distance of this line. I notice that this line has the length of 1, 2, 3, 4 squares. I notice that the length of that line has a distance of 4 squares. I don't know what 4 squares represents in length actually. That is when I have to use my x-axis right here and use it as a ruler to figure out what does 4 squares represent. Let me check out the chat. Yes, Janet, it will represent 2 pi. Let me go ahead and show everyone why that's the case. And actually, a lot of you knew that because I could see in the Google form, y'all put 2 pi as B. But that's not the answer. But I just want to say you all knew the period. But then after that, there was a little bit of struggle to figure out what the B term was. So I'm going to figure out what 4 squares represents because I'm going to go up to my x-axis and I'm going to count 4 squares. So 1, 2, 3, and 4. Once you count 4 squares, you notice that the length of 4 squares is 2 pi. So therefore, this length is 2 pi. That's my period. That's P. Cool. We have P, everyone. That means I could go back to this formula right here that I kind of paused on, and I could plug in for P. We figured out that P is 2 pi. P will not always be 2 pi. Sometimes it changes. P can be something else. Let me go ahead and just substitute 2 pi for P here. Now the next part, we need to solve for B. At this point, like you could try to see if anyone knows what B would be. So we have the equation 2 pi equals 2 pi divided by B. We could kind of figure out like 2 pi divided by what B value gives me 2 pi to figure out what B is. Or you could do the strategy of cross multiplication. Both of those are going to get you the same answer. So in order to, let me go ahead and show you all the strategy of substitution. So that's the first way. I could look at this and be like, well, the only time 2 pi is equal to 2 pi divided by something is when that something is equal to 1. So if I have 2 pi equals 2 pi divided by 1, I'm going to get 2 pi equals 2 pi, which makes sense. Like, yeah, that's a true statement. So you could do that if you look at this. Or the other way is you could do cross multiplication to solve for the b term. How you do cross multiplication is, first off, let's convert this left-hand side into a fraction. I'm going to say 2 pi divided by 1. Next, once you have that set up, you could do the strategy of cross multiplication. I'm going to multiply the absolute value of b over here, and I'm going to multiply the 1 over on the other side. Once you have that set up, you're going to have 2 pi times the absolute value of b. And then you're going to get on this side 1 times 2 pi. 1 times 2 pi is just going to be 2 pi. So I'm just going to go ahead and write 2 pi. So then our goal is, once again, we want to solve for b. And in order to solve for b, we'll do the opposite of multiplication. I think I asked this yesterday, right? Like, what is the opposite of multiplication? Let's see what's in the chat. Yes, we see that the opposite of multiplication is divide, specifically by 2 pi. Y'all see that in the chat? And if you have questions on why that's 2 pi, hey, feel free to ask. But the reason why it is 2 pi is because we want to get b by itself. Our goal is to solve for b so that we can tackle this b term right here. So then we get that the b value, oops, I gotta still divide the other side. You do it to one side, you gotta do it to the other. So then we have that the absolute value of b, I'll check the chat right now to see what y'all say, is equal to, okay, so it's equal to pi question mark. Well, let's see. So actually 2 pi divided by 2 pi, anything divided by itself, for example, 3 divided by 3, anything divided by itself is equal to 1. And pi is just a number. So the same is going to apply here. Or you could even think of doing this, crossing out the pi's, and you have 2 divided by 2. That is equal to 1. See how it gets you the same answer as when I kind of plugged in before? So the absolute value of b is equal to 1. Remember, absolute value just makes whatever's inside positive. So we could, in this case, just say that b is equal to 1. I'm going to go up here, and I'm going to, let me take this out. I'm going to say that b is equal to 1 according to that setup that we did with the blue equation. Okay, does anyone have questions about how we got b right now? That is a 1, by the way. Let me fix that. Is a 1. Let's see what's in the chat. Oh, sorry. How did you get that line through the graph? The orange one? This one right here? Oh, I thought that was red. I don't know if I'm using orange or red. This one right here? This is when I found the amplitude. In order to find the amplitude, you have to first draw your midline through the graph. The midline is a line that cuts your graph horizontally in half, like equal parts. And what you do is you start from the midline and you count to find your amplitude. In this case, our amplitude was 1 because we went from -5 to -4. The distance between these two numbers is 1. And that's how I had the amplitude, which is up here, of 1. So that's where this line came from. I drew in the midline. That was to address a question. Yes, of course. Okay, Any other questions so far? Yeah, and you could totally ask me about amplitude, or anything about what I just did to solve for B right now. Okay, everyone, you ready for an example of phase shift? Let's do this. Okay, in order to do this example for phase shifts, I'm going to kind of erase the work I did for the the period and stuff because I need to kind of draw my graph. I'll keep the other stuff though. So let me go ahead and erase stuff. Uh, I'll keep the midline. Okay. All right, everyone. So for this one, let's take a look at our parent function. I need to see if the sine function moved, um, if the sine function moved side to side, or that's called horizontal movement. So remember, y'all, the sine function, its parent function, starts at 0, 0. This is its start point. But notice how in this new purple function, it doesn't look the same, right? It doesn't start there. The starting point, you could think of it as various different ways. First off, you could think of it as, okay, the start point shifted this way to here. You could think of it like that. So shift to the right that way. Or you could think of the starting point shifted to the left this way. Either one will actually get you an equivalent function. And we could, play around with that. So for the sake of simplicity, I'm gonna kind of choose, just because I never did an example of phase shift with y'all, I'm gonna go ahead and choose, but like I wanted to let you know that you could think of this as a left shift or a right shift. I'm just identifying where the start point could be. You could even use these other ones, to be honest, like this one here, this one, it would actually give you an equivalent equation that represents the same graph. So it could be any of those, but I'm just going to choose kind of like the first right hand one that I see. So I'm going to delete this. No, I think, yeah, by midline. Midline's gone. I want to put it back because I feel like it kind of helped us see better. Okay, so it shifted to the right, but like how many units did it shift? Like where in the world, like what, how many units did this shift to the right if this is the starting point? So it's supposed to start at 0. So this is supposed to start over here at the x value of 0, but it got shifted to the right by this amount. So I'm going to just, I don't know, draw a little dotted line to kind of see what that number would be. And it looks like it's a number between pi and 2 pi, kind of like right in the middle. So what's a number that's directly in the middle between pi and 2 pi? We have pi 1/2. Do you mean pi over 2 or pi and 1/2? 1.5 pi? Okay, so someone says 1.5 pi and someone thinks 1/2 pi. That's okay. That's a great check. So let me go ahead and plot where pi over 2 would be at. So pi over 2 is basically half of pi. This is the location of pi over 2. And then there was the one where it said about 1.5 pi. There was another answer that said 1.5 pi. And I'm thinking, let's see, so between pi and 2 pi, and looks like, I mean, would you all agree that in here would be like 1.5 pi? Like, was that a direct message or did they say that publicly? Okay, it was a private message. I got the answer as 1.5 pi. And how we could do to verify that is so it's basically a number in between pi and 2 pi is what we're getting here. So between pi and 2 pi, it has to be right directly in the smack dab middle. One way you could verify that is basically, you know that pi is equal to 3.14. And you also know that 2 pi is equal to 2 times 3.14. Let me just multiply that on my phone. I got 6.28, which we knew before, but I just want to make sure I verify. So basically a number between 3.14 and 6.28. We just want to check that that's right in between them. So I got 4.71. Y'all can check to see what y'all are getting. I'm just basically multiplying out the pi, the 3.14. I do. Yeah, that is smack dab in the middle. So I just verified it. So all I did is I added 6.28 plus 3.14 divided by 2. It gave me 4.71, which is equivalent to 1.5 pi. Let me pause. Does anyone have any questions? So we have just right now figured out that this function has shifted to the right by 1.5 pi units. That's the phase shift. Let's see if there's questions. Okay, cool, cool. But if questions come up, let me know. I do know that once we do look at the big ideas packet, I think I did include another example of a phase shift so that y'all can take a look at that. Because it might be that the sounds y'all make do have a phase shift. So it is important to like for us to stop and talk about this. Okay, so we figured out its phase shift. By the way, it's perfectly acceptable if you gave me the decimal answer or the pi answer, because these are both equivalent anyways. So whatever works for you. Next off, okay, so we figured out its phase shift. It shifted to the right by 4.71 units or 1.5 pi. Another thing I want you all to note is, do y'all remember that, like, for example, when you were moving parabolas like side to side and stuff like that, do y'all remember that when you move to the right, it was a minus, and then when you move to the left, it was a plus? I don't know if y'all remember that, but if you don't, I'm gonna just put it right here. So moving to the right is going to be a minus inside of parentheses. I'm going to show you what I mean. But before we start to use that, let me go ahead and identify the phase shift right here. So let's go ahead and now tackle this formula. The phase shift is defined as C over B. So I'm going to go ahead and show my work over here. So phase shift is equal to C over B. Luckily, everyone, we already have B. We said that B was equal to 1. And not only that, y'all, we also have phase shift. B was equal to 1. We have that. And we also have the phase shift. We knew it moved to the right by about 1.5 pi or 4.71. I'm going to use the pi version though. So there's our phase shift. So that means we're almost going to be able to solve for B. So let me plug in what I have. So I'm going to put the phase shift was 1.5 pi equals C divided by my B. I'm just kind of like color coding it so you can see what I plugged into the phase shift. That's supposed to be orange. There we go. And In order to solve for C, you could do the same strategy I did here. You could cross multiply, or you could take a look at this and be like, well, C divided by 1, anything divided by 1 is just the number itself. So then C is equal to 1.5 pi. So this shifted by 1.5 pi units to the right. So C is going to be 1.5 pi. Let me know if anyone had that, by the way, on their Google form. That's my C right here. That's my B. My A, I already deleted the work, but my A was over here. All right, everyone, last thing is, what is D? D was actually another one that had a various amount of responses. So let's go ahead and talk about that. And I'm happy I drew the midline again. So D is basically the Y value at which the midline is intersecting. The midline, see down here, y'all, is intersecting at the Y value of -5. So my D is -5. That is where your midline is intersecting. Let's see if there are questions. And then we're going to put this all together right now in a sec. Okay, let's put it all together. So let's write our formal equation. So y equals, we have a is 1. We have sine of my b was 1, so 1x. Then we move to the right by 1.5 pi. So that's where I'm going to bring in this fact, y'all. When you move to the right, this is going to be a minus. So that's just when you move to the right, if you remember that rule, that's a minus right there. But my C is still 1.5 pi. And my vertical shift is exactly where your midline is at, -5. We can simplify this. So I'm going to simplify this. Y equals, we don't really write the ones. When you're multiplying by 1, we just kind of drop it. It's going to be x minus 1.5 pi minus 5. And that would be the equation for this sine wave. By the way, you could have equivalently done a cosine function for this in the same way. And do you all know that with cosine, there is no phase shift because actually cosine starts at its maximum. So just so you know, that is also possible and perhaps easier. Does anyone have any questions about what I just did overall on how we got this? So again, I felt like it was so important for me to go back and just redo all the steps again so that it's more clear. So hopefully that was more helpful to y'all and your questions that you brought up in the Padlet. Let me just pause for questions. If there's no questions, the next thing we're going to do is the big ideas packet. We're going to all annotate that. Okay, so there's a great clarifying question. So there's not always going to be a phase shift. That is right. If you're lucky, your sound wave will start right here, like this parent function for sine starts at 0, 0. So sometimes there is a phase shift, sometimes there's not. But I feel like when it comes to your sounds that y'all are going to make on the mini final, it's likely that you will have a phase shift. And again, I could send this video as well so that y'all have a resource to look at. Yeah. And then when is the final due? So the final is going to be due after spring break. I think I'm going to be making it due on the Tuesday that we come back from spring break. But as you all know, you are able to resubmit it as many times as you want to improve, whatever score you get. But it's going to be due like the final after spring break. If you're asking about the draft, that's going to be due tonight. Sorry, tomorrow night at midnight. Sorry. Let me go ahead and write that out so that one's clear. So draft, that's just a draft, Friday midnight. Final version is due after spring break. That way, like when you come back, you'll have a draft that you can revise to proficiency. So that's like basically the goal here. Any other burning questions about this or about, anything coming up for us? All right. I'll also make sure I upload this recording and I send it on Remind because we had a lot of questions on this. So this will be a useful resource. Don't worry, you'll get a copy of this. Let me transition us into our big ideas. So unfortunately, we didn't get to really have some time to look at the mini final together. Um, there were some cool like sound recordings that I want to kind of share before we jump into the ideas. And I'm on slide number 11. So props. I want to kind of share the different sounds people are recording on the mini final. So here's one. So that was a whistle. And the person who did this whistle, their graph looked very nice, like a nice smooth kind of sine wave. Here's another sound. So this person knows how to play the guitar, everyone. So they actually were playing a note on the guitar to create their wave. Look at the various, like it's so unique. Isn't this cool? Let's see what else we have. That sounds like the thing that wakes me up in the morning, the alarm, which is cool because y'all will be surprised. You get a nice wave with this one too. And let's go to this last one here. So this student put in kind of like their favorite kind of musical piece. And actually also, if they stopped it at the right location where the constant pitch is happening, they get a nice sine wave. So those are just various different things you could do. Or you could do what I did. If y'all see the research video I made, I tried to sing a note and I'm so bad at it. That's why my waves weren't nice. So just so you know, when you check out that video. Okay, everyone, let's move into annotating the big ideas packet. And what we're going to do is basically, due to timing, this is going to be our checkout. Let's go ahead and the whole class, we're going to add a comment. You're going to add a comment as a question, or you're going to add a comment that rephrases your understanding. Or like if you see someone having a question and you know the answer to it, you're going to answer that student's comment if you'd like. And yes, you can comment more than once. So I'm going to go ahead and put this into the chat so we can all do this exit. And yes, this is the last part of today's credit. So you definitely want to do that comment. Yay. Okay, also let me know if you're able to comment too. The access sharing sometimes becomes an issue. Okay, we have about 9 viewers in the big ideas packet. Let's go ahead and all get in there so we can get our final credit. And then that'll be your last math class until like 2 weeks, right? Until after spring break. We got 9 total viewers. Let's all get in there. I think we're still missing like 11 of us, no, 10 of us actually. Not 12 of us, I think. Okay, we're back up to 9. Yay, more of us are getting in there. We got 11 total viewers. Props, 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 and also props to the anonymous capybara. Capybaras, aren't those at Peru? That's what it looks like, I think. They look like a guinea pig. All right, we have 13 folks on this big ideas packet. Again, the goal is to just, you definitely want to make sure you take the time to familiarize with it, like what are the different resources. But go ahead and just add a comment as a question or a rephrasing of your understanding here in these last few um, minutes that we have left. We have wait, how do you comment? Okay, how you comment is like take a look at my screen. Let's say I'm going to comment on this. What pops up is these things. So this says add a comment, and then a comment box pops up. Another way you can do it is you highlight the same thing. Let's say that you don't see this popping up for you. You go up to near where it says share button, and there's a little comment, and you could comment. And that's how you can add your comment as well. So there are two different ways to add your comments. All right, we're good. I see a rephrasing of understanding. Waves can represent sounds and moves in height. That's right. So waves can can represent things like sound waves or even motion. All right, we have an understanding, a rephrasing. This table definitely helps you compare kind of like degrees and radians. I definitely agree with that. And I know there's probably some comments up above, but I'm just scrolling down to see if anyone chose to go down here. So there's going to be some interesting things as you go down. Perhaps some of them could be new. And this kind of correlates to kind of the stuff we did today about how to solve for the parameters A, B, C, and D. And I added in an example right down here that has another phase shift. By the way, everyone, if you go to page 12, or basically if you go to the big idea number 10, I included a screenshot of a student sample that submitted part one of the mini final. So definitely take a look at this resource as well. Yeah, and below that, by the way, like near the end of the big ideas packet, you get some stuff that are kind of more advanced thinking. So if you're like feeling like you want to go that extra, like read down from number 11 and below, and then you'll see some nice stuff. All right, everyone, do make sure you go ahead and add in your last comment. This is our checkout. I do know period two is starting soon, so I want to make sure you all head there. All right, everyone, thank you so much. See ya. Bye, everyone. Have a nice break.